Good morning, everyone. It's time for another quick lesson. This one should be pretty short, and it's on a very basic concept that hopefully you get really fast. And the basic idea today is the difference between a rational number and an irrational number. And I'm going to be quickly teaching you that difference. You should get it really fast, hopefully. The most basic difference is in the definition, and that is that a rational number can be represented as a ratio, or otherwise also as a fraction. So think about the word rational. Hopefully that makes you think of reason, the brain, thinking, order, things that make sense. And that's the idea behind rational numbers. It means that they're numbers that they're either whole numbers, or they might have decimals, but those decimals end, 4.2, 4.5, 8.619, not decimals that go on forever. So examples of rational numbers are any whole number is a rational number right off the bat, because it can be represented as a fraction. 4 is the same as 4 over 1, right? But there are decimals that are rational numbers. Don't get the relationship between rational and irrational mixed up with, say, whole numbers and decimals. It's not the same thing. There are plenty of decimals, or numbers with decimals, that are rational numbers. For example, if I were to divide, 6 into 10, or divide 6 into 10, that'll simplify 6 over 10. Which is the same as 3 over 5. And 3 over 5 will simplify as a rational number, because that fraction is 0.6. 0.6. That is a decimal that ends. It's just 0.6. 3 over 5. It can be represented as a ratio or a fraction. Now, an irrational number cannot. You cannot. There is no ratio. There is no fraction that can represent these numbers. They're just numbers with never-ending decimals. For the most notorious example of this is pi, which you've used a little bit, and you'll use a lot more next year in geometry. But pi, everyone knows it starts out as 3.14. But it's way more than 3.14. It never ends. It's 3.141592. And it literally never stops. Another example would be the square root of 2. Now, this is how the relationship between rational numbers and irrational numbers relates to what we've been studying about radicals and square roots. You might be wondering, this seems random out of nowhere. It's not, because there are rational numbers that are roots, and then there are irrational numbers that are roots. So an example of an irrational number that's a root would be the square root of 2. If you plug that into your calculator, square root of 2, it's going to give you some long, never-ending decimal, 1.414213, on and on and on and on and on. You can't represent the square root of 2 as a ratio or a fraction in any way. But you can represent the square root of 4 as a rational number. It's just 2. So, if you need to write down a definition in your notebook, which you should, write it down like this. A rational number is any number that can be represented by a ratio or a fraction, meaning when there's a decimal, if it has a decimal, it ends. An irrational number cannot. Now let me know if you have any questions. This will be used in your upcoming parts of the cumulative task.